Whoa, okay. So welcome back, everybody, to another session of CE 374U Urban Stormwater. We got an exciting day for you today, where you're going to get a chance to work on your projects in class and come ask me and Becky any questions you have as you're working. So today is really kind of your first day, really getting started on your preliminary designs. So I will be doing my best to help you as you work through that process. A couple of quick announcements before we get started, and then I will mostly just let you work today. First, homework 5 is due Monday. So that is the assignment on culverts and detention basins. Are there any questions on homework 5, just in general for the benefit of the class? Yes?
For problem 2, outlet control, is it submerged because the tailwater is bigger than the diameter?
Yes.
Or do we have to do like that check?
Oh, you should do the check to make sure that.
Check and the slopes are about the same, but the SF, the first is a bit lower than the actual lateral.
Right. So I guess spoiler, it's going to be submerged because otherwise you'd have to do the direct step method, which you're not going to do. So yes, you can treat it as being fully submerged. I think in the problem statement, it might say that it's fully submerged. I'm not sure. Flowing full. Yeah. Yeah. Okay, cool. Any other questions on homework 5? Yes.
Can you explain again the difference between abrupt transition?
Yeah, so that'll just have to do mostly with the shape of the outlet structure. So a gradual transition, you will have kind of a more a gradual opening up, and so you'll experience less local losses or less expansion losses than you will with an abrupt transition. So an abrupt transition is an abrupt transition in the shape, usually from a smaller cross-sectional area to a larger cross-sectional area. And so you'll get energy losses due to that transition. But yes, yeah, if you have more questions, I can come and talk to you today. Okay, cool. So today, are there any other questions on homework 5 before I move on? Any other questions? Okay. So today we're going to mainly be working on your course project. So today I want you to specifically work on your tasks for your preliminary designs as listed under homework 6. So just to review, each of you by this point should have your preliminary design task assigned. So 2 of you will be working on culvert and channel modifications. 1 of you will be working on a detention pond design, and 1 of you will be working on a land cover redesign per group. Okay, and the specific tasks for each of those designs are listed under here. So this is somewhat open-ended, but I have provided you questions to help you work through this process. So in general, for the culvert and channel modifications, you will be modifying the culvert and channel around your low water crossing in order to better meet the DCM requirements for the headwater elevation on the roadway. For detention basin, this is a bit more open-ended, but you're essentially designing a detention basin to reduce the flow rate at your low water crossing such that you can better achieve DCM requirements for the headwater elevation. And this is a bit open-ended in terms of what you can do with the design. So you can have just a detention basin upstream that's, reducing the amount of flow entering the channel network, or you may have a diversion basin. So it's kind of attached to the main channel through a diversion structure. There's many things you can do with this design. So if you have questions on how to implement this, I'm happy to come around today and help you work through it. And then finally, the land cover changes. So this is essentially working with GIS data to try to understand how you can reduce the runoff in your contributing area by changing land cover within your watershed, with the ultimate goal of reducing the flow at your low water crossing and thus reducing the flooding at your low water crossing. Okay, are there any kind of general conceptual questions about each of these design tasks? And I will be coming around today to help you through this process. But again, I've provided questions here to kind of help you work through the design process for each of these. Okay, a couple things I wanted to make you aware of. So I wanted to show you a couple of, before we get started, I wanted to show you a couple of GIS data sets that can be helpful in this design process, especially if you were in the latter two designs, so the land cover and detention basin designs. So the first one I wanted to bring your attention to was the hydraulic spatial and hydrologic spatial data sets available through FloodPro. You can also download this through the GIS data links. Or sorry, I think I have under pages here, I should have FloodPro data links. So you can also download this here. But if you go to FloodPro, you select your watershed and you select the hydraulic spatial and hydrologic spatial data sets. These will provide you some GIS data that essentially lines up with your HEC-RAS and HEC-HMS models that can kind of help you determine where your low water crossing is and what parts of the network you can redesign to achieve your flood reduction goals. So I'm going to go ahead and open these up in ArcGIS just to show you what they look like. So I'm going to be working with the hydraulic spatial and hydrologic spatial data sets for Shoal Creek. Hydraulic spatial corresponds to the HEC-RAS model, and hydrologic spatial corresponds to the HEC-HMS model. So it kind of gives you a crosswalk between the GIS data and the models, which will be helpful. Okay, so I'm going to go and create a new map in ArcGIS, hopefully. It's kind of weird. Oh. All right. Oh, okay. There we go. All right, so I am opening up a new project. What I'm going to do is I'm going to go to map. I'm going to add some data. So first, let's take a look at the hydraulic spatial data. So I'm going to open up the hydraulic spatial data for Shoal Creek. I'm just going to go ahead and select all of these. So again, you can download this from FloodPro or from the Canvas webpage. And you see that this kind of gives us a GIS file corresponding to the HEC-RAS data. So I don't have a mouse. I'm going to try to zoom in here with my pad. Okay, so you can see it kind of shows where the HEC-RAS model lives in terms of the geographic area. You have 4 different data sets here. You have 2, I'll just show each one of them in turn. You have a 25-year floodplain shapefile. So this gives you the floodplain corresponding to the 25-year storm event. You have the 100-year floodplain, which is a bit bigger. You have the stream center line. And then probably most important for your needs is you have the cross sections. So these are the locations of the cross sections in your HEC-RAS model and how they line up with the actual map. So for instance, you can look and see, you can click on an individual cross section and you can find its station. So this provides a good way of verifying where the cross sections are in terms of its actual geographic location. So for those of you who might have had trouble locating your cross section on the map, this is a good way to do it. Again, what I did was I clicked on that cross section, I went into the attributes, and you can find the stream station under those attributes. So this is its unique ID. Okay, so that is the hydraulic spatial data set. The other one that will be useful for you with respect to the models is the hydrologic spatial data set. So I'm going to open that up here. This is again for Shoal Creek. I'm just going to go ahead and grab all of them. And I will turn off the, oops, okay. I will turn off the HEC-RAS data real quick. Okay. And what we've downloaded is basically the extent of the HEC-HMS model. So you have the overall watershed boundary. You have the individual boundaries for each tributary. And importantly, this one is really important. You have these subbasins. So this provides a way of finding what the contributing area is for your site and also determining which subbasins you will need to modify in order to reduce the flows downstream. So for instance, let's say our low water crossing is right here, like at this junction here. What I can do is I can just select all of the subbasins. Oh, that was a little more difficult than I thought. In any case, you can select the subbasins that you're interested in and just export those. For instance, if you go to data, layer from selection, now you have a selection of subbasins that drains to your site, for instance, right? So the subbasins are going to be really useful. These line up with the exact subbasins in the HEC-HMS model. So these are very useful data to have, okay? Those are the main ones I wanted to show you. You can also find the individual tributaries. So it has the stream center lines for your HEC-HMS model. And also it has the actual stream network. It should have the actual stream network for Shoal Creek as well. It's not that one. Okay. Yeah. So this is a useful data set to have, especially for the land cover and detention basin parts of the assignment. Another data set you might want is if you go under GIS data links for the detention basin, there's also this high resolution Texas DEM data. So this can give you high resolution DEM data, digital elevation model data, in case you need it for deciding how much to cut and fill for your detention basin. So this is very high resolution data. Essentially, you just pick the site you're interested in and you go to digital elevation model and download it. The final data set I wanted to draw your attention to is this land cover data set. I'll talk more about this on Tuesday, but if you go under files in Canvas and go under GIS, you'll find this data set called Planimetrics 2013. And this is essentially a GIS file describing the land cover for every parcel in Austin. So I'll go over this on Tuesday and show how you can use this to estimate land cover within each subbasin. But I just wanted to show you what it looks like really quick. So I'm going to go and I'm going to load it for Austin. I'm actually going to zoom in because otherwise it will take a really long time to load. I'm going to turn all these other ones off here. If we go to data, GIS, should be listed as Planimetrics 2013. If I load this data, it will give me the land cover for basically every parcel in Austin. I need to zoom in more, or else it's going to take a really long time. So let's just zoom into this little part here. It fills up the entire space. And if we want to see what each of those land covers is, we can go to symbology. Instead of single symbol, we'll go to unique values. And for the field, I'll go over this again more slowly on Tuesday, but for the field, we can select feature. And it will give us the land cover of every single parcel. So you can estimate how much is pervious and how much is impervious, and thus how much you can modify in terms of the land cover. So here, I'll just show you a couple different ones. There's different land uses in here, including structures are one of the main ones. So that's all of these buildings. You'll have different kinds of remaining pervious area is probably the biggest land use, and that's all of this kind of orange space here. But this just provides a way of estimating the existing land cover and how much you can modify. And I'll cover this in more detail on Tuesday. Okay, aside from that, I will go ahead and let you start working, and I will come around and answer any questions and come talk with you as needed. So please feel free to flag me and Becky down for help, okay?